This introduction will provide an overview of the key features and capability of Spss. Of all uses of Spss, the first one is data management and preparation. Here there are three uses to be mentioned. The first one is to enter data. Data entry can easily be processed in Spss. And the second one is the data cleaning, and the third one is data transformation. In data entry, it will make efficient data entry and define the variable types and the formats. What kind of variables are to be used can be highlighted here. In the data cleaning, we focus on missing data, and we will decide upon these data and the outliers which are not relevant to our study, and the inconsistencies. As we commonly know in research, maintaining consistency is mandatory. And data transformation mostly focus on recording, computing, and transforming variable to prepare them for the analysis. So these three uses should be given emphasis. And the next part is the descriptive analysis. This is the first part of Spss output. The first one is the frequency. Frequency, mostly it's about the percentage. In relation to frequency, we can have also the measure of central tendency and depression of variables. The mean and standard deviation should be addressed with Spss. And the second one is the crosstab. Cross-tabulation is about relationship between categorical variables. What are the categorical variables? They are the variables like binary, nominal, and ordinal variables. And the third issue of descriptive statistics is visualization. Here a sort of illustration can be easily presented using charts and graphs in Spss. And the next part is about inferential statistics, and here there are 3 points to be mentioned. The first one is the hypothesis testing. The Amharic translation is already put in the bracket, and the regression analysis is also possible in inferential statistics and the multivariate. The hypothesis testing can easily be done with t-test, ANOVA, analysis of variance, and other tests to determine the statistical significance using the p-value. And the regression analysis can easily be linear, logistics regression, or ordinary regression like using the Likert scale. Multivariate analysis, it uses advanced techniques like the factor analysis that we will discuss in the next slide, and the structural equation modeling for complex analysis. This is for a complex analysis. And here the next is about the correlation. The correlation is about the relationship. Here our focus is on the Pearson correlation. Here we can easily see that Pearson correlation is used to measure the strength and the direction of linear regression. The XY coordination linearity can be checked, particularly by focusing on the strength in the direction. of linear correlation. And the next part is about the one that I highlighted in the slide just before. It's about factor analysis. Factor analysis identifies the underlying factors that explain the relationship among a set of variables, a group of variables. More than two variable relationship can be identified or exhibited. Cluster analysis, it's about group case of homogeneous clusters based on their similarity. And the last one, dimension reduction, is simplify complex data by extracting the most important. Here, the issue of prioritization or focusing on the important one should be addressed. There are two types of parametric tests. The first one is parametric test, and the second one is the non-parametric test. Parametric test mostly used when we make assumption about the parametrics of the population distribution from the sample is drawn. Here what is common is the population data is normally distributed, evenly distributed. The most widely used tests are t-test, paired and unpaired, ANOVA, one-way, non-repeated, or two-way or three-way. ANOVA can be exhibited. Linear regression and Pearson rank correlation can also be manifested. And the second one is non-parametric, is the opposite. It says in other literatures it is distribution free. As such, it can be no normal variable, and they are commonly used in Kruskal-Well and Minhorsten of non-parametric alternatives of the two variables. Non-parametric tests can also be min-1 U-test compared to independent samples when assumption of the t-tests are not met. And Kruskal-Wallis is extend the min-1 U-tests to compare to more than two independent samples. Here it compared two independent samples. This one compare more than two. Whilst on signed run test, analyze paired and repeated measures when the t-test is not violated. In the conclusion, Spss is a comprehensive statistical software that offers a wide range of tools for data analysis and visualization. As a research method, statistical technique continue to evolve, and Spss will expand its capability to meet the growing need of social science researchers and practitioners. Thank you for listening, and we'll meet with the next lecture. Have a nice time. Goodbye.